Okay, we're going to go ahead and get started. A little bit of housekeeping first. Obviously, we want to say thanks to our sponsors. So for this one, it's RecruitWise and Telerik, or Telerik, I don't know how you say it. Both of them. What? Telerik. I guess they're here, I guess. But, without them, we wouldn't have food to eat or a place to be. So thanks to our sponsors.
What's that $100 discount?
Contact your user group leader. $100 discount. I'm sorry, I forgot to make the slides. I just dropped them in there because I was told to. Sorry. Actually, I did edit this one. So this is a double length session, which means you get twice as much as me. I am planning on stopping halfway through and giving you a break. Because I need it, and that will give you an opportunity to gracefully exit. If you want to exit and stay exited, so but also give just a chance to breathe and so forth. We're going to talk about it. I loosely have it broken up this way. So in session one, we're going to go through the two different platforms, and the intention really is not for this session to be an adversarial piece to talk one about the other so much from a competitive standpoint, but more so that when you walk out of here, you'll have a good understanding of what the strengths of one is versus the other, how they fit, how they compare, so you can make a better decision of where one or both of them fit or don't fit in the type of work that you're doing. And then we'll talk about some of the cloud primitives and sort of things that they're doing. Session two, we're going to focus more on where the blood has been spilt in our working, where things have been bad, where things have been good, that sort of thing. And then we'll actually look at a little bit of code doing the same thing in both platforms to give you an idea of some of the similarities and disparities. The biggest thing I want to do is for you guys to learn or get out of this what you're looking for. So if you want to interrupt me and ask questions, please do so. This is a long session, so I'm not going to say wait till the end to ask questions. Just stick your hand up or start talking. I don't care either. The key, again, is for you guys to get something out of the session. If all I do is sit and talk and give you PowerPoint slides, we'll all be asleep, and that's not beneficial. I seriously considered yesterday not using any slides, but I wasn't sure I was that interesting. So the slides are hanging up for me. So has anybody heard, his name's Vittorio, the guy from the access control guy from Microsoft Speak. He does a PowerPoint slide or presentation where he actually builds his slides while he's talking, and then goes back and runs through them. He's an amazing speaker. He's a much better speaker than I am. I'm going to try to do that. So stepping back quick, how many people have heard me speak before and know who in the world I am and why? Okay, for those who don't, I work at Oak Ridge National Laboratory. Quick background, Oak Ridge, we do a lot of computing. Supercomputing is the thing we're probably most known for. I work in the Computer Science Research Group, which the majority of our group is focused on building tools for other researchers to use the supercomputers at both petascale and exascale moving forward. That is not me, so if you're interested in all that, I'm sorry, wrong person. I'm the red-headed stepchild in our group who's focusing on sort of the other end of the spectrum, which is where cloud computing fits into the computational profile, the types of things we do. So as you can imagine, there's a broad range of science that we do at Oak Ridge. Some computation fits very nicely across Jaguar, which is our super that has 225,000 concurrent processors, but many of our codes don't. Actually, the majority of our codes don't. So we're looking at where cloud computing fits into that space. What types of things fit there, where it can be used, and can we use it in ways to offset some of the load on our other supercomputers? So that's the space I'm in. And a lot of my talk will be based on that. In that role, we've been using private clouds a bit. We've been using Amazon quite a bit. We've been using Microsoft quite a bit. We've been involved in some of the Amazon private betas for some things. I'm also a Windows Azure MVP, so fairly well balanced master of all things, or Jack of all trades, master of none. Sorry, I spoke yesterday in Seattle, and I've spoken now more than I've slept since that point, so I'm a little bit rough on the edge. We were at a Microsoft research event yesterday on cloud computing. We were talking about a number of things. It was kind of funny. The way they do things at these academic talks is you have a block. You have 1.5 hour, 2 hour blocks where they'll have 3 or 4 speakers. You each give a topic, and it's rapid fire sessions. So you get up, give your talk. You sit down. The next person does. The next person. You kind of do that in blocks of sessions. I did not properly read all of the abstracts before I got in mine, and I was right in the middle. So in our block, we went from beekeeping in the cloud to nuclear science in the cloud to Walmart. Okay. The guy before me, I read his title. It said beekeeping moves to the cloud, and I thought he was going to talk about something really novel in swarm theory, mathematics, and stuff, being that the type of conference. And no, he was talking about tracking the habits of beekeepers in the cloud using cloud computing assets. It was actually a really interesting talk. It was very easy to stay awake because he kept showing these videos of swarms of bees. Very interesting. So types of clouds, jumping in a little bit. So private infrastructure platform. This and the next one sort of gives an idea. I want to set the ground for what we're talking about. As I talk with a number of the different cloud vendors, with the exception of Microsoft, so even them to a degree, they like these names less and less mostly because they're kind of fuzzing on the definitions. But as someone speaking and someone explaining to others, I like them because it gives us at least the grounds for discussing where people fit. So private, obviously, if you're running a private data center, you own and manage everything. You have the entire stack, you're responsible for it, patching management, deployment, everything. Infrastructure as a service, most commonly represented by Amazon in this case. Applications, runtime, security, integration, you own, but the actual physical infrastructure is owned and managed by Amazon. And in the platform as a service, sort of stereotypically represented by Microsoft, all you worry about is the application. In theory, everything else is managed by them. This is another way of looking at it, and probably does a slightly better job. So you either own the car, you're renting the car, or you ride it on someone else's train. But you still get to where you go, right? You have some control. Thanks, like that. So this does not represent any secret magic knowledge. This is simply the way things are kind of going where I'm expecting them to go, particularly. So if you go back 2 years ago, it was very clearly distinguished. Amazon was infrastructure as a service. There was nothing really other than that. They were there. That's where they were. Microsoft or Windows was particularly a platform as a service. And if you talk to many of their marketing people today, you'll still, we are platform as a service, blah, blah, blah. If you look at their current offerings today from both vendors, you see they're kind of fuzzing that line. Amazon, while still primarily infrastructure, they have some offerings that are more platform as a service like. If you look at, for example, Elastic MapReduce, that is nothing other than a platform play. Some of their other products like Beanstalk is much more of a platform as a service play. In Microsoft, while they tout the values and virtues of platform as a service, and while they say infrastructure is nothing more than commodity stuff, there's not very much value added there. They're still offering things like virtual machine roles, and there's a lot of talk about making those even more interesting. So they're kind of leaning both in the opposite direction. The economy is becoming fuzzy. I'm expecting, this is Rob's opinion, so I probably work very little, that if we move out another 2 years, these two very clear lines will get very, very fuzzy, and they'll simply just be slightly different offerings for them. It's not to say that they will be offering the same things, but the delineation between the two platforms will be much fuzzier if existent at all. So the Amazon stack, spend some time here. So Elastic Compute Cloud, so this is their compute, what basically I'm going to do is walk through these, give a high-level description of them, and the same for Azure, and then we'll sort of walk through some comparisons of them. Elastic Compute Cloud is the name for their computing offering, so virtual machines in the cloud. You say, I want N number of virtual machines, they give you it. You have root access. If it's Linux, you get you can SSH directly in the box. If it's Windows, you can RDP directly in the box. If it's your machine, you can install whatever you want to on it. They do have pre-packaged machine images. They call them AMIs. Think of them as a VHD or a virtual machine that's pre-configured with some amount of software. But generally, you get a base machine and you can do whatever you want to it. So long as it's on, you're paying for it. When you turn it off, you're no longer paying for it. Very clear. Elastic MapReduce. Anybody play with Hadoop? Anybody know what Hadoop is? Okay. So it's 2 more people than most. So Hadoop is a means for doing large-scale distributed programming on commodity assets. What Amazon did is they watched the people as they were using their cloud. They saw so many people using their cloud platform for Hadoop that they went and actually productized it to make it easier for those folks to do it. So you don't have to use it, but many people are simply because it's click button easy, right? If I have a Hadoop job, I can upload my package, upload my data, configure it, and say go and do it. That is very much a platform as a service play, right? It's much like the Windows Azure platform is, and even GAE is to a point. They give you a programming paradigm, and if you write your code such that it fits in that paradigm, you simply upload it and say run this way, and it does. Magic happens, right? Auto-scaling, well, their compute can auto-scale. This is actually a surprisingly new feature. So, considering how much it's been talked about in the cloud, every time you hear someone give a talk about the cloud, they talk about the nodes. Assets are cheap. You can scale up when you need to. You can scale down when your load goes back down. Sort of burst scale things. But the dirty little secret is up until just recently, none of the vendors provided you the magic to do that. Right? They provided you all of the APIs, but it didn't actually do it. So just recently, by recently meaning within the last 6 months, Amazon came out with the ability for you to use in combination with the Cloud One product, which is over here, to define some rules. It says, I want you to watch these machines, and if the processor utilization is over X for X amount of time, or the memory usage is over such and such for a certain amount of time, then take this action. Scale up the machine, create an instance, etc., etc. So it gives you an ability to auto-scale. CloudFront is their CDN, so content distribution network for the masses. We'll talk about that a little bit more later. SimpleDB. Any NoSQL fans? So SimpleDB is their take on NoSQL. It's not exactly NoSQL, but it's closer to it than, say, MySQL. But think of it as schemaless. I like to describe it as Excel in the sky. So one big Excel worksheet, you can stuff whatever data you want into it and ask questions of it. Relational database service is MySQL and now Oracle, actually, on demand. So when we are talking about the compute cloud, you can actually stand up an instance, deploy MySQL to it, you can deploy Oracle to it, it's fine. The difference with the relational database service is they handle the infrastructure tasks for you. So you say, I want a MySQL instance, and they stand it up on their hardware, they handle the load balancing, they handle the patching, you just access it as a database server that you already have. Same with the Oracle instance. Simple storage service, this is sort of where they've made a huge name for themselves. It's their storage platform. Blob storage, you can think of it as a great place to put files. Everything has a URL. It's URL accessible. They've done a lot of innovation over the last few years to make it more interesting, but it's just raw, more or less limitless growth storage in the cloud. So big disk in the sky. Elastic Block Store, this is generally considered an inward-facing NAS. So if you're doing compute within the Amazon environment, so I'm using EC2, I can access EBS as a NAS on that environment or within my environment. So I can set up a storage endpoint, mount it, or maybe SAN might be a little bit. SAN's actually probably a better description. So because there's a one-to-one mapping for reads for writes. So I'm mounting it. I can read data from it, and you can do some interesting things like snapshotting your volumes and things like that. More or less, it looks like a SAN. Simple Queue Service is cloud-based queuing. Simple Notifications is PubSub in the sky. So if you're doing PubSub notifications or message busing, you can do that. CloudWatch we mentioned. Virtual Private Cloud. Virtual Private Cloud is interesting. It is sort of a part of their gateway drug collection. Meaning it's a mechanism to help people who aren't ready to jump into the cloud to get into the cloud. So what it is it's an IPsec endpoint. So if you have compatible hardware in your environment, you run your existing data center, you can basically create an IPsec tunnel between a VPN concentrator on your environment and the Amazon cloud, and have assets in the cloud behave as if they were on your local network. You can configure them so they cannot get out to the internet other than through your tunnel. So you can essentially burst, but still have full control of the internet communications to those machines. It's a very safe way for people to sort of dabble in the cloud without sort of jumping all in. And there are some really interesting scenarios that it enables, but it's really I say gateway drug. It's really a way to get you comfortable without jumping in full bore. Elastic load balancing is, well, it's the load balancer. So it's a load balancer as a service. As you deploy your EC2 instances, you can set up rules and say, I want these 3 nodes to be behind the load balancer. Here's the IP address I want you to use. Here's the rules I want you to use for balancing the traffic, etc. Import-export is an aspect of their storage platform. So there's this famous statement that says, never underestimate the bandwidth of a station wagon loaded with disks going down the highway. And this is simply a technological acknowledgement of that. So they have a number of customers who say, I've got large amounts of data, terabytes, petabytes of data, and there are simply physics laws that will prevent me from using my internet pipeline at home. One of them being Comcast, from getting all of that data up to you in time, right? In any measurement. I mean, we work at the lab, we have an incredible bandwidth pipe, still moving terabytes of data, or petabytes of data across that. It's just, it's insane. So they actually have a formalized program in an API by which you can say, I'm going to ship you a number of disks, and here's where I want you to, here's basically my tracking number, here's where I want you to put them in my storage account. They'll accept them and do them, and they charge you some overhead fee for that, but it's substantially less than, say, the network charge for actually uploading it, and the time scale is significantly lower. They also have the reverse. So if I'm saying I've got a bunch of data that I've generated there, or I want to put data there that other people can actually subscribe and pull down at large scale, I can programatize that such that they will ship disks out to people. CloudFormation is the ability for me to say, we'll give a concrete example of this a little later, either in this talk or the second hour. I have a sort of an environment that I want to define in a file. I want to say, here, I have a scenario or a product that requires 2 web heads, an application server, a SQL server, an elastic load balancer, or something like that. I have this configuration, and I want to define that as a bundle and be able to either programmatically deliver it in, if you will, a single click. So I can define it all in my file and say, here, provision this, or deprovision this. Or I can sell it using one of their other services. I can actually use Amazon DevPay to say, I've got something interesting here. I want to define it in such a way, and then sell this to my users. And maybe the rates that Amazon would charge are, say, 8 cents an hour per CPU. I want to do an upcharge of 4 cents an hour on top of that. Amazon will charge the customers on my behalf using their DevPay, which is basically a bill on behalf feature. The customer will get charged 12 cents an hour for those instances. I get the extra 4 cents, Amazon gets the 8, everyone's happy. An Elastic Beanstalk is, I didn't ask, is anybody using GAE, Google App Engine? So the way GAE works at a very high level is they provide a programming interface by which you write to, you deploy your code, and then they have constraints by which they auto-scale you up or down, right? If your traffic is to a certain spot, they scale you out to more nodes and bill you accordingly. If your traffic starts to drop off, they lower you back down. The Elastic Beanstalk is essentially that for the Amazon cloud. You get to define it a little bit differently rather than Google simply doing it, but that's essentially the feature where it fits. Any questions on that before we move on? Yes?
Does EC2 have a storage, or do you have to use the EBS as a storage?
So EC2 has, there are ephemeral disks, but they are non-persistent.
So can you explain, for example, if you create an EC2 instance, you use as a web server.
Yes.
Where do we put the actual files? Do we put it on EBS or?
So in my best consulting mode, it depends. Which is actually a good, the proper answer. There's option one says, well, there's a handful of options. So if I'm just doing traditional web scale, right, my web server is more or less stateless, right? So all it's doing is buffering traffic, right? Saying I'm essentially it's a protocol server. I'm accepting traffic here, providing a little bit of logic, and then serving up files. The general case for static files is that you put that in S3 and buffer it through. S3 is a persistent store. Okay. Now let's take the next step. It says, well, my instance has some state or has some logic or configuration data, right? So when I have one of those instances, I have to configure it. One of your options is to use EBS, so you can boot from EBS, and we'll talk about this a little bit more in just a few minutes. So in EBS is sort of your SAN-based volumes. So when I shut down my instance, that SAN volume still persists, so I can reboot it and bring up my state again, right? There are pros and cons, significant pros and cons to that, right? Another model says build your webheads purely stateless with a script, such that I have some base config that's in my AMI, and then I have a script that goes along with it. So when I spin up a new instance, it spins up that instance and then applies logic in the script to get it to a state where it's actually usable to me prior to adding it to the load balancer, right? That latter case takes significantly more work up front, but gives you much easier ability to scale down the road. I can simply say, give me another one, give me another one, give me another one, rather than saying, I need to spin up a new instance, and I need to copy these files over, and I need to make some configuration differences. So that's why I say it actually does depend on what you're trying to do.
So if we use an EBS, is it a manual work that they have to create an instance and map it to the EBS volume? Do you have to log into the server and do that?
You can do it, you can script it, right? But there are, again, the pros and cons to that. And particularly in the second session, when we talk about recent events in the Amazon cloud, we'll talk about why you may or may not want to use EBS as your sole source of data. Okay? Any other questions before we move on to Azure? Seems really behind.
Where's Mechanical Turk?
Well, so it's funny, if you go to the Amazon website, if you go to AWS and you pull down the list of cloud services, they've got things like Mechanical Turk listed there. And there's a collection of things on there that I'm like, I'm not sure what is stuck in there. I mean, they're services, and there's a part of me that thinks they're stuck under the AWS umbrella because Amazon doesn't know where else to stick them, right? It's not part of their bookstore, and it's this internet service thing, so let's stick it under AWS and call it cloud service. Mechanical Turk is cool, and I actually listened to a talk out at this Microsoft research event where there's a group from Berkeley who's studying the well, because one of the things that's interesting with Mechanical Turk is there's an API for it, right? So you can essentially, there's an API to people, right? So they're doing some interesting studies on sort of the proper scale rates for certain problem sizes with real people behind them. And there's all sorts of really interesting things that come into play there because it's not simply like general compute work units, because it's what type of work are you deploying to people. How do you incentivize them properly? What's the proper incentive rates? Because you get to set how many pennies you're going to use for each of those rates and things like that. And then there's also the BS factor. How do I help people know that this is actually real work and not just someone experimenting on top of you? There's some really interesting human interaction studies there.
It's definitely analog computing, like Bessel was talking about last night.
It is. It's very much analog computing. But it's hard for me to think of it as a true cloud service, right? But it is an interesting one. The one thing I want to talk about EC2 here before we go. One of the things that they've done really interesting in their cloud pricing model, and I'm assuming some things here, so forgive me for that. I'm assuming that you're all sort of order of magnitude familiar with the pricing models in the cloud. For those of you who aren't, it's essentially pay by the drink. You pay X cents per hour for compute, for the amount of time that your compute instance is deployed to an actual server, whether or not it's running or not. So that means slightly different things between the two platforms, but if I'm taking up physical hardware on a physical virtual host, when I'm running serving things, or if I'm just standing there sort of ready to serve things, I'm paying something, right? One of the things that Amazon's done that I think is fascinating, frankly, is they've essentially created a commodities market for unused cycles. So they have fixed rates for their on-demand services that say, you know, if I go to them and say I want XYZ number of compute servers per right now, they're going to say that's 8 cents or 12 cents or whatever, 48 cents, whatever it is based on the size I'm choosing. And I can have those right now. But there are certain types of workloads that I really don't care when they get done, so long as they're done within, you know, some fuzzy period of time, maybe the next week or so, maybe over the weekend sometime. But I don't care if they happen at 2 a.m. or now, so long as they get done. And maybe I'm willing to sort of gamble with the market and pay a little less. So they actually have a mechanism by which I can say the going rate is 8 cents an hour for the instance type I want to use. I can say, well, I'm willing to pay 6 cents an hour. And I essentially place my bid for 6 cents an hour for however many hours and however many nodes, and that goes into their queue management system. And as they have enough compute cycles become free, that the market price for those unused cycles drops, my instances automatically get spun up, allocated, my job can run, and then I'm done, they shut off. Another validation reason for using S3 back store, so sort of script-based things. So depending on the type of workload, that's a really interesting way, for them to backfill unused cycles, because they want to, you know, obviously they're incentivized to have them fully utilized, but also to sort of gain me into using it more because I feel like I'm getting a deal because I'm paying less per hour for that. Another key thing with both vendors is that if you're going to use a certain number of servers, essentially 24 hours a day, 7 days a week, so rather than simply doing burst, I'm actually outsourcing a fixed amount of work. They do have subscription plans, prepayment plans, they call them slightly different things, where that hourly rate drops significantly. You make some sort of commitment, and they give you some sort of reduced rate, and it works out better. So if you find yourself in that case, take the time to look at their other options. And you can mix and match, right? So I can say I'm going to use 4 servers solid for the next year, but then I'm going to do on-demand pricing for my work above that spot. Windows Azure Stack. So this deck, or this slide, is a little old. So some of the names, some of these are code names that have now been replaced with formal names. But this is essentially their stack. So we'll start at the bottom and work up. Their storage platform. We have table storage, which is their take on NoSQL. We have blob storage, which is, well, their blob storage. So again, think binary large objects, files, any sort of thing like that. Completely unstructured file, bit writes. Queues is their cloud-based queuing mechanism. Drive is not quite EBS, but it's sort of a mappable set on top of blob storage. Okay, so but it's specifically not EBS, though it has some EBS-like behaviors we'll talk about. And then their content delivery network. Windows Azure Compute is their compute structure. It's much like Amazon, they have instance sizes, so I can say I want the small instance, the medium instance, large, extra large, whatever. I actually have a micro instance now, and I'm willing to pay X cents per hour for that. Unlike Amazon, though, I do not get root access to anything. With a slight caveat that we'll talk about in a few minutes, for the most part, it's black box computing. So I'm getting that virtual machine, but it's not Linux, if I needed that, but it's Windows Server 2008 R2 for the most part, and it's just running a code package that I've uploaded. Data is SQL Azure. They have not decided to offer MySQL yet. The SQL Azure in the cloud, that's much like the RDS from Amazon we were talking about earlier. It's fully managed SQL. I don't have to worry about it. I simply say I want a SQL database and assume that you take care of all of the backup, restore, maintenance, all of that good stuff. Data sync will hit in a few minutes. Connectivity, Windows Azure Service Bus. This is where you can do pub sub, much like the Amazon stuff we were talking about. Windows Azure Connect, that allows you to do point-to-point VPN connection between something in your environment and a machine in the cloud. That's very different than, say, a router or Amazon Virtual Private Cloud. It's not gateway to gateway, it's point machine to machine. Okay? There's talk of that changing, but today it's that way. Access control is sort of a security layer for providing federated identities. So if you're building applications for the cloud, it's a security layer by which you can allow people to log into your application using their Google account or Facebook or Twitter or whatever that sort of thing. Framework, Dublin and Velocity. It's more Velocity right now, so they have a cache. So if you're doing significant web caching or web server hosting, web content hosting, database access, you can use Windows Azure Cache to buffer that and improve your performance and scalability. The application services, they have Microsoft Pinpoint in their Dallas platform, which has now been renamed to, I think it's the Data Marketplace or Data Market. And that's the ability. The data market's interesting because it allows people. It's sort of a brokerage for data. So if I have, say, I have Navtech, right? How many of you have a personal contract with Navtech? How many people know what Navtech is? So Navtech is the mapping company. They provide all the mapping companies behind the GPS stuff. The likelihood that I would ever have a contract with Navtech is less than small, but services like Data Market sort of facilitate that. What they've done is Microsoft has brokered relationships with these, or provided a mechanism by which these companies who sell and own large, expensive data can actually offer that up at a sort of a cloud-friendly mechanism. So maybe the first X number of account or requests are free, then there's tiered things that's based on usage, et cetera, all the way up to some very expensive access requests. You can get weather data, you can get all sorts of data. Some of the data is free, some of it's very specialized and very expensive. The big key takeaway, though, is that there's no contract that you have to manage between yourself and these services. All you do is you sign up with your live ID, read the terms of service for that particular data source, click go, and start using it. It's very, very easy, very friendly. Common API across all of the services, so making mashups significantly easier. It's a pretty interesting spot. And Pinpoint is the ability for me, if I build a Windows Azure application, to bundle that up in a package and then sell it as a feature in the marketplace. So maybe I have Rob's famous web-hosted guest book, because people need those, I guess. I could bundle it up, all of the code logic and everything, put it there, and then they would sell it. I would get some fixed fee. It does differ from the Windows or from the Amazon bill on behalf of, in that I'm setting a fixed fee for the purchase of my software, not for sort of a concurrent long-term running arrangement. Whereas the Amazon bill on behalf says, I'm bundling these services and I want you to, I sort of want to get money every hour that that compute instance is running. Any questions here before we go on to the break? Before we go on to the next one. Okay, storage. So now this begins sort of the more direct comparison. So we're going to go through a number of the different categories that we've sort of. The point of the last two slides is sort of to get you familiar with the terminology. So as we're drilling through here doing direct comparison, you're not wondering what we're talking about. So in each of these, so long as I did it right, Amazon will be on the left, and Windows Azure will be on the right. So S3 is more or less analogous to blob storage. If you've done any work with them, they're almost identical. There's a few primitive differences, but the way they behave, the way you upload files to them, they're almost identical. The big thing is that with S3, you're sort of the root of your namespace for your file systems is what they call a bucket. In Azure, it's called a container. But beyond that, it's free-form namespace. You can use slashes in your names to give the appearance of folders. They both behave very similar that way. They both, as of now, this used to be different, but as of now, they both support chunked and parallelized uploads. So if I have a large file, I can do local chunking of it, then parallelize my uploads, and then the service on the remote end will automatically recompile that into a single file for me. If you visit my blog and go back about a year, I did a lot of work on that as far as maximizing upload transfer speeds, and you can see massive improvements in doing that on more common networks. So if you have large files, be it video files, really anything over order of a couple of megs, it's worth at least looking at that. The same, they both support byte range gets, so you can do the reverse. So if I want to pull down a big file, I can do a head request, get the file size, split it up, parallelize my gets, reassemble the file, and maximize the transfer that way. EBS. So we talked about EBS is their internal NAS. That is a separate storage. One of the key things here is EBS is separate from S3. So EBS is a completely separate infrastructure. It behaves separately. It has different SLAs around it. It is tied locally to the same physical data center, whereas S3 may be spread across, for redundancy, is spread across multiple data centers. So, but EBS behaves very much like a SAN. So I have a volume that I can mount. I can mount it to only one machine at a time for read-write access. I may be able to share write or read-only snapshots of it with other instances. I can, in fact, snapshot it, that sort of thing. Very similar with Windows Azure Drive. The difference, though, is that Azure Drive is built on top of blob storage. Now, that's not quite as different because blob storage right now in the Windows platform only lives in one data center that you select. So when you set up your account, you say, I want to be in the US North Central region or US South Central region. That is currently today one physical data center. All of your data, your blob storage, while it does have triple redundancy, it is in one physical data center. It's not split across multiple data centers as Amazon S3 is. Pros and cons there. We'll talk again some more about that in the redundancy section, the resiliency section in the second talk. SimpleDB and table storage are more or less equivalent, just that SimpleDB is easy to use. SimpleDB has this notion of domains. A domain is roughly equivalent to a Windows Azure, or what they call a table on the Windows Azure side. It's basically the name of your spreadsheet. So if we carry that spreadsheet analogy out further, it's simply the name that you put on that spreadsheet. It's the means by which you query things. This is something I've actually made a big stink with the Microsoft folks on, because SimpleDB is sort of, if you were ignorant walking into the space, SimpleDB works the way you would think it should. It's almost everything's indexable. I don't have to think about it and say, here's some data, here's sort of what I want my columns to like. I upload it using their API. I can ask questions of it. It's very SQL-like in my question asking, and it scales reasonably well. Windows Azure table storage can arguably scale better than that, but it's better when you're in the billions of rows, right? So unless I'm in the billions of rows, even when I'm in the 4-row count, this enforces some overhead on me that I don't frankly need when I'm at 4 rows. So this is great, it scales great, it's really interesting, but there's an overhead. If you pick up any book or read anything on using Windows Azure tables, they talk about you have to choose your partition key right, you have to come up with your naming scheme, and they don't index every field, so they only index the primary key and the partition key. So there's all of these things they do that gives you this massive scale, but if I'm only just wanting to stick a little bit of data there, it's really painful to get over that first time. From a querying standpoint, it uses ADO.NET data services, so if you're familiar with that sort of structure, it's very easy to use as far as querying the data. SQS and queues are very, very similar. The primitives are very similar. They're durable messaging queues. And what's key to this in a number of apps is that there's a 2-phase interaction. So you don't just pop a message off the queue. You have to pop it, rather than disappearing or being deleted off the queue, it goes into a hidden state. And because when you pop it, you provided a timeout. Or if you don't, it has some default timeout. Maybe it's 20 seconds, 30 seconds. You can set it to whatever you want. But when I pop it, it basically goes into a hidden state. I perform some operation. When I've actually finished doing the operation that was represented by that, I go back to the queue with the primary key and say delete this item. If I never come back, when that timeout expires, it actually reappears on the queue, which is actually really, really good for web scale, cloud-oriented things, right? Because all of these platforms are using commodity boxes. We expect things to fail. My machines will go down for whatever reason, right? Either it's being patched or there's just a hardware failure or whatever. It will go down. So using durable message queues is a really key aspect of architecting properly for cloud storage. Their queues on both sides work almost exactly the same. Constructs names are a little bit different, but behaviors are functionally identical. CloudFront and CDN. So both of these work similarly. They both sit on top of blob storage and S3 respectively. And in both cases, there's simply a checkbox that says for this container, for this area, I want to enable the CDN. What they then do is give you a new base URL that you use instead of your existing URL. The remainder of your path remains the same. And then using that, you now have a pull-based CDN available to you at cents per hour worldwide. Now, today, these folks have a better CDN network than those folks do. But depending on what your scale is, that may or may not be a big deal to you. They have it because they're pushing things like Windows updates around the world, and they've had to build out their CDN network for very specific reasons, right? But you're essentially sitting on top of theirs, which is great because how many of you have looked at Akamai and have a contract with Akamai? You actually do?
Yes.
You've looked at it? You actually have a contract with it?
We have a contract with them.
Wow. First person ever. Are they cheap?
I don't know about the rates because I'm way too low.
Okay, they're crazy expensive, right? They're really, really good. Akamai is one of the best ones out there, but they're expensive. And the problem is as such, unless you're a big boy and really, really, really need a CDN, you're never going to get signed up with them, right? These two services from both of these vendors allow anybody to take advantage of CDN for small level websites. You know, say you're mom and pop shop, if you have some big files and you have a worldwide presence, it's a great way to use it. Easy way to get into it. And AWS Import Export only, Microsoft does not have anything comparable right now. I haven't even heard mumblings about it, but they don't have it. So it may be.
They're working on it.
What?
According to Brian Prince, they're working on it.
It wouldn't surprise me. It's a common enough problem.
Yeah.
Though, who knows what Brian knows, right? Databases. So this is so similar to Amazon, they call this the relational database service, or RDS. Windows Azure, it's obviously just MS SQL versus MySQL, Oracle, and then they both have, Windows Azure has SQL Sync, which is a tool that allows you to sync your SQL databases between multiple instances. So if I have, when I set up a Windows Azure or Azure SQL instance or SQL Azure instance, I choose a zone that I want. I can say North Central, South Central, Europe, whatever. I can also create an instance in another zone, and then I can use SQL Sync to keep them in sync. Or I could create a database locally in my on-premise environment and use SQL Sync to keep them in sync. I have that flexibility, so they provide me the tool to do that. Now, that's great, but I am paying for network traffic between those. So it's just a caveat. Anytime you leave their data centers, you're paying for network traffic, right? Amazon has this notion of being able to do multi-AZ modes, multiple availability zones, which sort of automates the fact. So I say, I want to set my RDS up in their Northern Virginia space, which I think they call US standard. If I check the box that says, do this in multi-AZ mode, they automatically replicate into another availability zone and handle all of the magic. So they're essentially doing much what SQL Sync lets me do, but they're just doing it automatically for me. They also charge a little extra for that same way. So it's not really a cost differential. It's simply a matter of how much control you have versus how much magic is happening for you. But the functionality and the services here are very similar. Compute. Okay, so Amazon Web Services, as we mentioned, you have raw VM access. So you depending on the OS type you get either root access directly with an SSH shell, or you get RDP access to a Windows box. With Windows Azure, it's more or less black box access. However, they just released a feature by which you can RDP into some of your instances. They heavily caveat it that says you really shouldn't use it much other than for troubleshooting things, but it does make it significantly easier to use and to troubleshoot. I was working on a problem just this last week where I was deploying some native C++ libraries and learned only after RDPing into it that there is no C++ runtime on the boxes by default. So, which I should have known, but I forgot. But that sort of debugging is very helpful. And that RDP access gives you that. But they specifically don't intend for you to use it as a constant state or to always be RDP'd in. So, for example, some people will set up in Amazon, they'll set up a couple of dev boxes and they just work off of that. So they'll come in the morning, they'll already pay to use that as their dev box. Microsoft stresses really highly, don't do that. Again, because they have no storage for persistence. If that machine goes down, they spin up a new one from scratch. Right? So there is no persistence for the ephemeral drives there. Amazon Web Services, we talked a little bit about EBS versus S3-based booting. So I'm probably not going to go too much further than that. Other than that, EBS, like we said earlier, allows you persistence. S3 has no persistence. Every time you're starting from a clean snapshot of that original base image. Like we said, there are good and bad things for that. The Windows Azure instance is very similar to the S3 base. Every time you start a new instance, you're starting from a clean instance of some sort. Whether you're using the VM role, they're starting from a fresh instance of the VM or the VHD that you uploaded, or they're starting from their base that they configured for you. EBS, one gotcha, if you're using the UI, there's this option to shut down and to terminate. If you shut down, everything's good, you can restart up, everything's fine. If you hit the terminate button by accident, it also kills your EBS volume associated with it, so you go poof. So don't do that unless you intend to. You mentioned their VM roles are not persistent. A couple of things that Amazon has that's unique are specialized nodes. And this is not necessarily interesting for everybody, it's specifically to us, which is I can get what they call they came up with this last summer, their cluster compute instance, which gives you someone who needs technical computing or is doing sort of high performance computing of some sort, whether it's true HPC or they're just heavy workloads, gives you raw access to basically an entire physical machine. You are still virtualized, there's still a hypervisor in there, but you're the only host on the machine. They also give you very specific details about the machine you're running on, so you know exactly what processor type it is. You know how much RAM's on the box. You have access to. So if you're doing processor-specific optimizations during compilation, you can do that. Another key piece there is if I take a collection of those CCIs and put them in a group, they will guarantee me 10 gig non-blocking network connectivity between those nodes. So if I want to do MPI, I actually can. And so much so that before they went live with the product, they actually they took 880 of these and ran Linpack on it, which, if you're not familiar, Linpack is sort of the benchmark for testing supercomputers. And they placed, at the time, 146 on the top 500 in the world list. And when the official list came out in November, they actually were in the mid 200s. So their cloud platform was actually on the top 500 list, which is kind of funny. Another thing they came out with is GPU nodes. So CCI nodes plus GPUs. So if you want to do any playing around with GPU-enabled computing, for, I think it's, last I looked, it's like order of $2.10 an hour, you can get a 8-way box with a large amount of RAM and 2 NVIDIA Fermi cards in it, that's a significant amount of compute. So much so, there's a German hacker who came out just within hours of Amazon announcing this. He demonstrated cracking SHA-1 for about $1.47 because he had the GPU nodes, right? So he wasn't doing. The SHA-1 hack had already been in existence, so he wasn't doing anything new. But it takes a significant amount of compute. He was demonstrating how these nodes are really, frankly, fairly powerful. Elastic MapReduce is, we talked about earlier, that it's an offering they have. Microsoft to date doesn't have anything like that. There are some, at the talks I was at this week, Microsoft Research, it's surprising to me how many people in the academic world are coming up with more or less very convoluted ways of running MapReduce on Windows Azure. So there's a lot of effort in that space, none of it's ready for prime time. So there's work there. You can do it if you really, really want to. If you really, really want to, I'd say use EMR or use Amazon. Sorry, guys. Networking. So Amazon Web Services, every time you spin up an instance, you get a private IP and a public IP. Okay, none of those are persistent. They go with the wind. If your instance goes down, those IP addresses go away. If you spin up a new instance, you get a new set of IP addresses. And that's not to say that your instances will always go down. I know people who've had instances up for 2 years at a time. I also know people who have had them up for a week and they got rebooted and cycled and come. That's the nature of the cloud. Those IP addresses are non-persistent. The same thing with Windows Azure. You have non-persistent IP addresses. Your IP address is automatically assigned and so forth. Key difference is you do have load balancing automatically. So Windows Azure has this notion of roles. So if I deploy 4 instances of my web role, Windows Azure automatically puts a load balancer in front of them and puts all 4 of those in that load balance pool. Your instances have this notion of startup tasks. So as my instance spins up, it can execute a few startup tasks. That machine does not get added to the load balancer until the startup tasks are completed and the machine is registered as healthy. So it's not, I don't have to worry about dropping connections and things like that, but it's automatically enabled load balancer. Amazon does not do that. They provide you the mechanism to do an elastic load balancer, but they charge you a few extra cents per hour for using their load balancer. They also do have what they call an elastic IP. So most people who are going to do production level things in Amazon Web Services will buy an elastic IP. An elastic IP is more or less a rented dedicated IP. So I say I want an IP and I want to know that it's not going away. You pay X cents per hour or something like that, and you have that for as long as you want. It's assigned to you. Most people will then assign that to the front side of their elastic load balancer, add their boxes behind it, and do their scaling that way. Virtual private cloud, we talked about a little bit, and Azure Connect, those sort of map up. The big difference here is that this is gateway to gateway, whereas that is point to point, machine to machine. So I can some people have actually done that. They've installed that on their internal Windows Azure or Windows AD box. So they put it actually on a directory server and then had one of their machines in Azure be a member of their domain that way. So it may fall in the category of just because you can doesn't mean you should, but you technically can't, right? Route 53 is Amazon Data Service. Came out with this. It's not been all that long. It's been an order of 4 or 5 months they've come out with that. It was in private beta for quite a while, and it's gone public here just recently. Microsoft does not have a similar offering. I bet you'll be on there twice, because I really want to make the point that you have to pay for it here, it's built in over there. Firewall. So in Amazon, they have this notion of security groups. Security group is essentially a firewall bucket. And you can define it with the same level, or much the same port level granularity that you would expect in a regular firewall. I can define groups and say, between this group and this group, only allow this traffic on these ports and these protocols, etc. From the public to this and this, you have what you would expect. And each group can be as small as 1 node. It can be as many nodes as I want. With Windows Azure, all traffic between the nodes is prohibited by default unless I define an open endpoint. So you have a specified number of endpoints. I think the number is 25 per deployment. So I can only have 25 specific endpoints open between any of my nodes in there. There's pros and cons, and in the platform as a service model that they're really pushing you towards, that's really not that bad. You rarely do hit that unless you're really trying to do something that really should be over there. Most people who hit this wall really, frankly, ought to be doing a more infrastructure as a service role. Okay, 50. Deployments. So Amazon Web Services, we talked about AMIs. AMI is what they call an Amazon Machine Image. It's essentially a prepackaged virtual machine. Think of it, if you're in the Microsoft world, think of it as a VHD, but specifically a sysprepped VHD. So you technically have to, it's generally that. It's a clean image before it's been deployed. You can configure it, you can add software to it, but it's been cleansed of all of the security identifiers on your network. So when it spins up, it goes to that initial first time boot. What's interesting with AMIs is that Amazon has a very wide third-party library of AMIs. So if you want to go test things, there's likely someone else has already built an AMI and prepackaged it with that software on it, so you can go kick the tires. An easy example is if you want to play with WordPress and MySQL in the cloud, you can go to the library, click a button, and in a matter of minutes you have one running. You don't have to download the software, you don't have to run anything. Sort of appliances, prepackaged appliances, if you will. Beyond that, it's traditional deployment models. It's a server. So the same way you would deploy code to Any other server you own is the same way here. If you use FTP, if you use SCP, whatever you would do, it's the same exact way. Use Git or whatever. It's the same thing. It's you do whatever you want to with it. It's a server. Yes?
Just curious, touch on eucalyptus or any of the local ways of doing this, or I don't know. I just wonder if it's in scope of what you're...
I wasn't going to specifically talk about. I can.
I don't know. I know this much about it, and it seems very... I'd sure like to know about it.
Yes, so eucalyptus. Anybody else know about eucalyptus? Anybody else care to know about eucalyptus? Anybody else not know enough to know if they care? So eucalyptus is a project out of, actually started off from a fellow DOE lab by a gentleman by the name of Rich Wolski. Eucalyptus is a private version of Amazon's cloud, is the short story there. So the idea is it's API compatible, so it's mostly API compatible, and it's very easy for me to take a collection of physical machines in my environment, deploy it out, and I can have my own cloud. Now, the internals and implementations are wildly different from what Amazon's doing, but the API is very, very similar. I can actually take a virtual machine that's been deployed to my Eucalyptus cloud, run it through some magic, and deploy it to Amazon, right, as an AMI.
Vice versa too?
No. The tools just aren't there right now. They have a subsection of Eucalyptus that's called Walrus. Walrus is more or less compatible with the Amazon S3, and it's API compliant as well. So I can deploy a local storage platform that is very, very similar from an API standpoint as Amazon S3 is. And such that if you use the Amazon tools, you can basically point them directly at your Eucalyptus instance, and they work. You have to do a little bit of differencing with the paths, but they work. Okay. The idea here, and the reason they built it is it was for research organizations to be able to stand up a little cloud, do some testing, and then when they wanted to, you will cloud burst. Not the way Amazon did in April, but to actually cloud burst to load up to the cloud to sort of scale. And there's been some interesting stories about it. Eucalyptus is really interesting right now. If you look at Ubuntu server, say 9 and 10, they make it brain dead easy to deploy Eucalyptus as a cloud. And it's called the Ubuntu Enterprise Cloud. And I'm a Windows guy, and I was able to successfully have it up and running in a matter of a couple of hours. Right.
You install Windows or Ubuntu server, and that's how I actually learned about this. Is it's an option when you're installing service.
You pop in the disk, like just say.
One of your two things is a real machine, or this is a Eucalyptus thing. It's like, what the hell is that?
Yeah, you stick in the disk, and one of the options is Ubuntu Cloud. You set it up. If you can simply take all the defaults on the first install, and it'll set up a cloud controller, your head nodes, and then you can add a couple of other physical machines, and it'll know that the other one's there, and it'll join it. Magic happens, right? And you have this little platform. And it's great for kicking the tires on.
It really is a practical... See, that's the thing. I was wondering if it's a practical way of actually doing integration testing before you push or do dev testing, that sort of thing?
It's essentially it's a great mechanism for doing dev testing, right? What's interesting about it, though, is Eucalyptus is sort of falling out of favor with the community as a whole. Now, Eucalyptus has gone from being a private project, there's now a commercial entity behind it. But the big sort of favorite new kid at the party is OpenStack. So OpenStack is a project being sort of jointly worked on between NASA and Rackspace and a large number of other people. And it is also similar in API to the Amazon platform. And Ubuntu recently announced that they are going to drop Eucalyptus in favor of OpenStack in the next version. So at this point, I'd be a little nervous hitching my wagon onto Eucalyptus.
Okay. Thanks. Thanks.
I'd be looking pretty heavy at OpenStack if I'm wanting to do a private cloud of some sort. Stepping back here, fine-grained updates. So when I'm deploying codes, I can deploy code because it's a server I own, and it's a server just like any other server. I can deploy a single file at a time. Whatever I would do on a local server in my environment, I can deploy that way. I do have more responsibility. I'm responsible for patches. I'm responsible for anything that I would be responsible for in a physical box. I'm responsible for here. If I need to defrag my disk, if I need to do whatever, antivirus, security, anything that's there. There's less magic in this environment, right? So with my deployments, if I want to do a new instance, unless I've scripted it really, really well, if I do a new EBS instance, I have to spin up the instance, I have to copy it, I have to configure my web server, I have to do all of that stuff, deploy the code. Again, not rocket science, but there's responsibility there, right? Elastic Beanstalk will help there, and that's sort of the auto-scale GAE-like pre-configured, pre-scripted scale-out mechanisms. And CloudFormation also is a package we talked about there. So CloudFormation doesn't really help with scaling so much as it helps my ability to predefine a logical collection of assets that I want to deploy or undeploy as needed. Windows Azure, CS package file. So that's how I push code to the cloud. Did I generate a CS package file? Easiest way to do it is to use all the wizards built in Visual Studio. They do have command line options if you want, if you're running on Windows. It is a fancy zip file, meaning in theory you should be able to change the extension from CSPKG to .zip and open it. However, they've made some, and they would admit this, some bad design choices and actually extended the zip protocol, the zip package file format to do some encryption security that prevents you from doing that. My expectation is that they will undo that in the future because it will allow them to generate CS package files on non-Microsoft OSs. They've got some magic built in there that they really wish they hadn't built in there. As such, that is my course, that's my level of update, is that CS package file. I cannot push an individual file. Okay? Now there are ways to work around that, right? So if I'm doing a web server, a website deployment and I have a lot of static content, best practices say that I don't actually deploy my content files, my static files to the individual web heads. I put them in blob storage. If I put them in blob storage, I can update them all day long without ever touching my deployed web servers, right? Now, if I have actual code libraries that go on the individual web heads, that has to be in the CS package file. There is another exception for this. If you're using a single instance, so if you're not using multiple instances, if you've enabled a single instance, they will let you enable a feature for doing web deploy from Visual Studio, so I can push into individual files. Now, the key there is if I'm doing web deploy in a single instance, all of their SLAs are not applicable. Their SLAs have the requirement that you have to have multiple instances running, right? So, pros and cons there. The web deploy option is interesting if you're sort of iterating through some tests, trying to get something working, and the idea is you turn that off and scale out. More magic happens here. What's nice here is once I have my mechanism working, I simply go into a portal or via the API and say, give me another one, give me another one, give me another one. And magic happens. They handle deploying it, they handle pushing up my code, they handle adding it to a load balancer when it's ready, they handle health monitoring, all of that good stuff. It just works, right? And it's actually pretty slick. Middleware. Let's see, where are we time-wise? Okay, a few more minutes and then we'll take a break. Middleware, Amazon Web Services, simple notification services, so that's their pub-sub model. Similar in notion to Windows Azure Service Bus. Windows Azure Service, I don't want to undersell this. Windows Azure Service Bus actually is significantly more enhanced here. It's got some more features as far as multicasting. It's a pretty intelligent app goes around it. Windows Azure has caching as an offering as well as access control. Amazon has CloudWatch and AutoScale. Again, Windows Azure provides you the APIs by which you can determine whether or not you need to scale, and you could build your own auto-scaling platform or sort of mechanism around it. They just don't provide it out of the box. There's no mechanism to say, if my web servers are hit 80% utilization for a sustained period of 5 minutes, add another one. I can't do that in their tool set. I can gather that information and then perform the action using their APIs. I just can't do it automatically. And then Amazon has this thing called Simple Email Services. basically your own spam server in the sky. I mean, email server in the sky. And that it's because of the joke with spam is one of the funny reasons, one of the reasons they actually hesitated to doing it. And Microsoft's best practices tell you not to deploy an SMTP server in their cloud because they know people are doing it and they know if members are doing it and they know that their IP radios will be blocked. So they strongly recommend against it. Amazon's working to do it with reasonable protections, but I'm not sure how confident I would be. It feels like a sharp knife, right? That may be pointing the wrong way. But it's an interesting feature. Let's see what else we got. Tooling. Amazon. So Amazon's tooling started with a command line. They were yes.
Is there any service for running cron jobs?
In Amazon?
Anywhere, Amazon or Azure.
So cron job is by definition Linux and by definition not in Azure.
Okay, but I mean like equivalent to Windows service that they provide as a feature.
Yeah, so in Windows Azure, if you wanted a service that runs on a regular period of time, you use what they call the Windows Azure worker role, which is essentially a Windows Azure service. It's a structure for providing a Windows Azure service, or like a Windows service that you would run on your box. Right? So you would do that, and you would do it much the same way on the Amazon side. You would simply set up a Linux box and then set up your cron job. Right? It's not pre-structured; you have to do it, but the mechanisms are there. So it's not packaged for you. So Amazon's, and I've tried to put these sort of in order of their popularity for the given platform. So Amazon's core strength is and always has been the command line API. They've started that way. It's great. It's rock solid. You can do everything scripted. Their command line sits on top of the REST API. Within the last year or so, they've made huge efforts to building a strong web portal. Prior to that spot, you were on your own. There were some third-party products that did some things to help you. Elastic Fox was one of them. It was a plugin for Firefox. There was a couple of other ones. But the web portal is really, it's come, I almost can't express how much better it is now than it was. It's actually very, very usable. And from I just want to kick the tires standpoint, it's brain dead simple to get going. With the exception of Eucalyptus and OpenStack, there is no local dev test. You're on your own. They assume that you're just going to interact with their actual services. Okay? Windows Azure Web Portal is their primary, or at least principal way of uploading your files initially. They actually have exposed the REST API. Recent changes to the Visual Studio extensions, by recent meaning last fall, so I guess that's not recent, allow you to deploy directly from Visual Studio. So for people who are iterating and deploying and are not in a formal deployment model, that's sort of how they've been doing it. It's great for that. You can, obviously, they have command line calls as well. Numerous third-party tools that's growing. They've not been in the business as long, so their third-party ecosphere isn't quite as what Amazon is. One big key difference is they provide a dev fabric. So I can actually run a simulated version of the Windows Azure fabric on my machine. That's heavily caveated in that there's things it doesn't do, there are things that it doesn't do quite right. I'm particularly not a big fan of the Windows Azure storage emulator. It slows, it bogs me down. I usually turn it off. It's one of the first things I do. I just interact with actual Azure storage. For compute, though, it's great because you can actually F5, you can set up multiple instances and F5 through them and do some things. So if you're trying to troubleshoot interactions between machines, it's great for that. Okay, just about perfect. We're going to stop and give you a 10-minute break like everybody else. You can breathe, walk around, do bio break, whatever. A couple of things to mention. Web address is my blog. The slides for this session and the next will be posted there probably by the end of the day tomorrow. On Twitter, please rate your talk if you want. That address will also be on the website. If this stinks, you're bored, you're falling asleep, tell me there. If it's interesting, whatever. Here are some things also of interest. Free access, you go to windowsazurepass.com and use the passcode Rob on Azure. you'll get 30 days free access. That's what these cards say. So it's the same thing. And then you can also go to Amazon, AWS.amazon.com/free, and get 1 year free access to a certain amount, to a limited set, enough to kick the tires and sort of do some, get some familiarity with the product. But you do need a credit card for that, so they charge you if you go over their limits. So with that, let's take some time and let's start up in 10 minutes or so. Okay, so this session is going to be a pickup off the last one. We're going to talk more about sort of lessons learned, things that we've learned from doing it, less about the product. So everyone was here last time, I think. So you all have a great, well-based knowledge of technology. So we can just assume and move forward. Again, this one will probably be a little easier. If there's questions or you want to have discussions, please feel free to engage. I love this slide. So, oddly, I was sitting at my desk at work on Twitter, and this was the first news I got that Amazon was down. They went down hard. So no one in the room here still is using Amazon for production. So I gave a talk on Amazon the 6th of May up in Ohio. So basically 2 weeks after the crash, and a number of people in the room had been affected by it, had production sites down by it. It was a very interesting talk. So they went down hard. They had a lot of issues and in a way, some people made a big deal about the fact that, hey, this is really bad. They went down, they crashed. It's bad for cloud computing. I actually took sort of a slightly different approach, in that I think it's good because it reminded people that cloud computing is not a panacea, right? It's a collection of tools that can allow you to do some really interesting things, but you still have to follow the directions. You still have to use the tools the way they're supposed to. So what happened? What is the most common cause of network outages or unplanned downtime?
Human error.
Human error.
Which is
same thing.
Everything.
So an Amazon engineer, they have not offered up his name, which he's probably very grateful for.
Is he still a boy?
They've not answered that question either. So essentially they were doing some maintenance on one of the network traffic links. And every time they do it, they redirect traffic to a particular link. And he rather than putting it on the main high traffic link, he put it on the slow backup link by accident. And as soon as he did it, he was like, oh crap, something bad. So he flipped it back. Well, with that, he did it just enough time in between that it caused a replication storm. So all of the EBS volumes in the affected zone started saying, we lost each other, so the multi-master mode went into effect. And it basically created a replication storm which took down the network for EBS volumes. Okay? There are a lot of things that came out of that. The first is that they learned that, so Amazon has this notion of availability. They said regions, and then within a region they have availability zones. A region would be like U.S. North Central, which we know because we can read the website, is the Northern Virginia area. They also have another region that's called U.S. West, which is Northern California. They have ones over in Europe and so forth. Within a given region,
is the region in the data center or multiple?
Hang with me.
Oh, sorry.
But good question. So a region in this case, so U.S. Central or U.S. Standard is the Northern Virginia area. Within a region, they have availability zones. So, for example, in U.S. North or U.S. Standard, they have availability zone 1A, 1B, 1C, and 1D. Now, technically, this is actually a copy from the website. Each availability zone is its own physically distinct, independent infrastructure. It is designed to be highly reliable. Effectively, it's its own data center, right? Separated by some distance, connected by high-speed internet. So each one is completely independent. It's supposed to be. So one of the things that happened as a part of this is that they learned that part of their replication traffic for EC2 was not completely isolated. They fixed that within the first hour. But more or less, it was isolated, which is good. So another thing that people got frustrated with is they kept updating their status on the website saying the affected availability zone is down, is having these issues and so forth. And a lot of people got frustrated because they said, well, why don't you just tell us which availability zone is it? Is it 1D? Is it 1C? So I can move my stuff off of it. And the reason is, and this again goes back to sort of reading the manual, is when I signed up for an Amazon account, I got assigned a particular mapping of availability zones. So it said Rob's availability zone mapping is 1A, 1B, 1C, and 1D. If Andy were to sign up, he may get 1D, 1A, 1B, 1C. Right? So they actually changed the name because what they learned is if they do everybody the same exact way, when everybody goes to provision a machine, most people take the default, so everybody ended up in 1A. So they were overloading one data center. So they basically do a round robin of sorts in your allocations, but it doesn't frankly matter because generally you don't care where it actually is. You just want to know that if I'm putting stuff in what I know of as 1A, I may, for high availability, put other stuff in what I know as 1B.
You don't care where it is once it's down.
I physically don't care. I technically still don't care where the physical locality is. I care about the logic, that it's logically separate. Right?
Can you, in some cases, care if you've got international widespread use you might want?
Well, so that's handled by regions. So the regions are only within a particular international boundary. So if I care about geofencing my data, I would pick a region that's in the geofence area that I care about, right? And that's obviously why there's so many, everyone's putting data centers in Europe, right? Because the EU has very strict geofencing data rules. So people who collect data over there can't put it in the US data centers, right? Things like that. But within that region, within that fence, I don't care where it is, right?
Right.
I don't care if it's in data center, in the northern part of Virginia versus the southern part of Virginia, so long as it's in that space, right? So the big question, I had a lot of conversations, I get sort of razzed every time at work, everybody walks by my office and says, to the cloud, and makes all sorts of smart aleck comments. When things went down, I got sort of the subsequent cloud, question jokes, is it raining, is it storming, is this lightning, what is it? But the questions really come back to some of these. Is your physical data center any better? Are the behaviors and the operations and policies and procedures in your data center any better? And most people, not all, but most people is not. Right? Then I asked the subsequent question, how would you recover if you had the same type of problem? What would your approach be? What are your practices? Have you practiced your fault tolerance and disaster recovery models? Do you have the tools and infrastructure to provide the same level of fault tolerance and reliance that Amazon or Microsoft are giving you, right? And that's really the key, is if you follow their rulings, if you follow their guidance, you can build a very highly available platform. See here. I'll kill time. Here's really the key, right? Saying the cloud ate your homework isn't valid. Right? The vendors have given you enough tools that if you architect properly, you won't go down. And that was demonstrated. There's a lot of postmortems from people after the Amazon crash. Companies like Netflix who stayed up during the entire time. Their entire customer delivery business lives on the Amazon cloud, but they didn't go down at all. There are a number of other companies who stayed up and rode the storm fine. There were also some really big companies who went down hard. And some of them have postmortems that are sort of mea culpas, like, hey, we didn't expect or we didn't plan, we just hadn't gotten to it yet. Others evidently didn't read the fine print and are still blaming Amazon. And it's not to remove Amazon from any obligation. They had an outage, right? Things were bad. But if those people who followed their guidance and actually properly used the tools stayed up fine. And while I'm focusing on the Amazon, the same things apply to Azure. Azure gives you the tools by which you can build a very highly available platform. But if you choose not to use them, you'll go down just as hard when they have their outage. They thankfully haven't had one yet, but if laws of statistics and probability are true, they will. Right? It's bound to happen. So, fault tolerance. What are the differences between the different instances? So, AWS has these regions, right? We were talking about them. So they have U.S. North Central. They have U.S. West. They have, I forget the names of them, but there's 2 of them in the European theater. They have 2 now in Japan. They have 1 at least in the Korea area, I think, South Pacific.
Singapore and
the Singapore area.
Hong Kong.
I don't think any of them incidentally have anything in South America. I was talking with, on the plane, when I was flying out to Seattle, I was talking with a gentleman who's Vice President of Sales for F5 in Latin America. I don't think there's any cloud data centers in South America right now. Anyway, there's a number of these regions. Within each region, they have their availability zones. So within that region, you have the ability to distribute your code, distribute your servers across availability zones, and therefore achieve redundancy. Right? I can set elastic load balancing, so I'm balancing servers across the availability zones. I can also set elastic load balancing so it's globally distributing my data. I can have a server in US Standard, US West, the Koreas, or Singapore area, wherever, and I can have that ELB spanning all of those. Right? I have that flexibility if I want to. Right? Now, obviously, that comes with extra cost, but it's still significantly less cost than if I were trying to do a geo-distributed, highly redundant platform on my own, right? Here's this flag. We talked briefly about this earlier, so relational database service. A number of people who went down were not necessarily using, so EBS is what went down, right? So compute stayed up, S3 stayed up fine, networking stayed up, or core networking stayed up fine, EBS went down. A lot of people said, well, I'm not using EBS, but I'm still down. It's because they were using their RDS, so the relational database service, which is EBS backed, right? So they sort of got it by proxy. What they didn't know, or many people didn't know, is that RDS has a flag that you can set that says enable multi-AZ mode, which automatically scales you or replicates you across multiple availabilities. Right? So one of their recommendations is to use that. Fault tolerance for S3. S3 is automatically fault tolerant. We're talking about this automatic. It's as soon as I upload a file into S3, it's replicated multiple times. They have a guaranteed reliability of 11 nines. Right? How many of you have that on your NAS at your office? Right? 11 nines. It's crazy.
Well, how did that outage factor into that? That right there would knock off a couple of nines at least.
Well, so reliability and availability are different numbers.
Yeah.
Okay. So they define reliability as the fact that when I upload a byte,
It'll be there.
it will be there, will remain unchanged, and will not deteriorate. Right? It doesn't necessarily mean I can access it. Right? Okay. So access rates are different. Right? It basically means the durability, if you will. So it's a durability ratio. Their numbers were so high that they actually have a new product offering called reduced redundancy storage. So if you don't need 11 nines and you're okay with 4 nines, you can pay for reduced redundancy storage, which is roughly 2/3 the cost of their full storage price.
I could live with that.
Yeah, I mean, shoot, the 4 nines is a lot better than what I've got at home, right? So the point is they've got
a Comcast?
they got highly redundant.
Maybe 2 4s.
Yeah, 2 4s. It's highly redundant. They don't go into a lot of detail about how they accomplish that. They do have, I know, a process that goes through and checks for bit rot and will automatically correct bit rot problems between the multiple replicas and multiple masters. It is distributed across multiple physical facilities. Very highly difficult. I put these on here. I don't have good answers for how for how durable these are across environments. The same that I don't over here for these. I don't think that SimpleDB I know has some resiliency. I'm not sure about the Q services as far as redundancy. Azure, the key here is multiple instances, right? So they have an SLA. I'm supposed to know what it is. It's something like 99.5 or something
It's
like
like
that.
3.5 or 4.5 nines.
Yeah, something like that. Only if you have multiple instances running. And the reason they do that is A, because they know stuff's going to fail, and they also have this notion of upgrade domains and patching fault domains and upgrade domains. So they will, because it's a platform as a service and they manage your patches in your box, they will periodically deploy new patches as the platform needs it. And they depend on this, because of this, when they allocate your machines, they never put them in the same upgrade or fault domain. They split them across so they know that they can patch one of your machines without taking down your entire environment. Right? Today, if you're using sort of the automatic magic deployment, you can only do that within one area, one region. So I can deploy to US North Central. I can deploy to US South Central. I cannot, in a single deployment, deploy to both. And there's nothing to say that I couldn't deploy the same code base to both and then use my own load balancer across them. But that doesn't come magic out of the box with Microsoft. Except for this new piece called Global Traffic Manager, which is coming. It's still in beta, but it's coming. And what that will allow you to do is essentially geo-distribute your traffic. So I can say, much the same way you would with a CDN for content, I can essentially geo-distribute my traffic for compute. So I can say, if you're coming from Korea, I want to send you to the data center close over here. If you're coming from the US, I want you to send you to the data center here. That also gives me the ability to say, hey, if this data center in the US is down, send everybody over here. Right? So they're coming up with that functionality soon. SQL Azure Sync, we talked about earlier, it gives the ability to replicate data between multiple SQL servers. That can obviously be across different data centers and or locally in my own on-premise environment if I choose. Blobs are, so let me step back here. So compare blobs versus S3. So S3, we talked earlier, we were talking about the Amazon Compute, you can choose a region, and then within a region you can choose an availability zone. So when I deploy compute, I'm saying, I want to deploy in the US standard region, and I'm going to choose availability zone 1A. The same for my EBS volumes, right? They go into, they have that level of granularity. When I set up an S3 bucket, the smallest level of granularity I have is a region. I don't get to select into the availability zone. And that's because they're automatically replicating my data within that availability zone. And they're handling all of that. So I don't have any finer grain control of that. Now, Windows Azure Blobs, they talk about triply replicating your data. They've not published how many nines they have up there. They certainly haven't claimed to 11 nines like Amazon has. But they say your data is triply replicated, they do bitrot checks, all of that good stuff. What's important to know is that's one data center. So when I put my data in a container in Windows Azure, I'm choosing an area like US Standard or US North Central, which right now is a data center in Chicago. That's one data center. That'll be triply replicated in there, but if, God forbid, a bomb drops on that data center, my data is gone. There's no geo-distribution of that, right? It becomes a risk calculation. I can decide whether or not I want to then replicate to other data centers. That's my own choice. But I would also require my own tooling as well. And mention the tables and queues. I have question marks on. I don't have good answers for. Design tenets. So, how do I build apps that survive? These points were taken from, amazingly, shortly after the Amazon outage and recovery. They had a webcast hosted on how to build highly resilient applications for Amazon Web Services, which I thought was sort of funny, so I joined. This was one of their slides from that presentation. And I included it because these are good points that, frankly, sort of transcend your particular platform, right? So first of all, use independent components, right? Loosely couple your application. Things that should be separate should be able to operate by themselves. So the second point, design everything as a black box. Allow pieces and components to operate independent of each other, so should one go down, the other thing, it doesn't necessarily take down everything else. Load balance and scale your clusters. So balance your load across multiple environments, multiple availability zones, wherever you operate, whatever your zone or your unit of scale is. Think about graceful degradation. This is one of the things that came out of the sort of Netflix post-mortem. They talked about how they had taken their website and their web presence material, presence offering, and they had assessed certain components and bucketized it such that if one feature tends to be taking long or is failing, they just take it off the page. They may not make a big deal about it, it just automatically happens. If it starts to take too long, they just remove it from the page. And most of the time, the customers don't even notice, right? And when they fix the problem, it just shows up again. So they have, their site can sort of scale down as failures happen and scale up automatically, or return back to normal service automatically. Using queues to isolate components, we talked about that a little bit earlier, the fact where fully durable queues come in and what they can do to provide both fault tolerance and things. One of the things I want to talk about here also is the Netflix example. So Netflix does something that I think is really great and really gutsy. They have this notion of what they call the chaos monkey. Have you ever heard of this? So when they moved into the cloud, they sort of adopted a whole hog. But they said, we know things are going to fail. Amazon's told us to design for things that things should fail. We know that's going to go down. How do we guarantee that we can survive that? So they actually wrote an agent or a service that they called affectionately the chaos monkey that randomly shuts crap off. So it runs all the time. It's just another server in their environment, and it just kind of watches and watches and watches and says, I'm going to shut you down. It kills the server. Just no one knows when it's going to happen. No one knows what role it's going to do. It may be a database server. It may be a web server. It may be a middleware application server. It may be anything, and it just kills it. Then it waits some period of time and shuts something else off, right? That's a really gutsy way to build your apps. But they were able to go through this without stressing at all. They knew it was going to survive. They've tested every single day because they know this is always running, right? They've designed for that. They've designed their environment to withstand failures. The interesting thing is that in their post-mortem coming out of it, their biggest lesson is they weren't quite sure that their chaos monkey was severe enough, because they said it does not today shut off complete availability zones. So they were actually contemplating adjusting and coming up with the chaos gorilla. That would actually, that's what they said, that would actually shut down a complete availability zone. Right? So to actually have a coarser grain killing to make sure that they fail over imbalance. Okay.
Has the chaos monkey ever failed?
I didn't ask them that question. That'd be interesting. That'd be very interesting. But would you know? That's right. But the point being is that Azure, that's really a tenant that should be in your current environment, regardless of whether or not you're in the cloud, right? If you're talking about high availability, if you care about that, you really should be testing your strategies, your recovery strategies. Where are my fault tolerance domains? If something goes down, how bad is it? How am I going to recover? All of that sort of thing. It just gets a little clearer when you move to the cloud. Application examples. So we'll talk through here a couple of different apps that we've deployed to the cloud and that we've deployed or tried to deploy to both of the clouds, and sort of the pros and cons and things we've learned about both. Anybody familiar with Protect? So Protect is an organization basically designed to help go after child predators and protect kids from being taken advantage of. So kiddie porn type stuff, abuse, negligence, that sort of thing. So Protect has a long relationship with the lab. We've done a lot of work to help build tools for various police departments to help them identify potential suspects. We actually have this magic thumb drive we can stick in a machine during a home raid that will come back in a matter of seconds with the probability of child porn in the machine, as well as giving an evidentiary findings for the cops, so they can say yes, that is, and take the guy in. Pretty interesting stuff. Some magic facial recognition, stuff like that. But we've been working with them on a number of things. One of the things they've been working on is they use a tool called, or many of the police departments, as well as ICE and others, use a tool called Access Data, or use FTK from a company called Access Data to do forensic investigation on hard drives. So once they've, the tools that we've worked with will help provide sort of that first level of evidence, basically enough probable cause to take someone into custody that is not court sustainable, right? You can't say, well, this thumb drive proves, right? There's a whole long litany of things that you can do to have a fully forensically accurate image. So there's companies like Access Data, there's another company, Encase. Those are the two biggest ones that do it, that basically have tools that will build forensic images that use hardware-based write blockers, all sorts of interesting things to come up with, to build the images, because you have to provide a forensically clean image to the defense, to all of this good stuff, right? The problem is this tool and process takes a really long time. And to define really long, if you have a 2 terabyte drive and you plug it into a traditional desktop that you find in most police departments running this tool, you're talking a 5-day window to do the initial indexing of that drive. That's before the investigation. That's just the indexing and generation of everything. That's a really long time. Many police departments, they have machines stacked up, and they have basically a 2-month queue for machines to come through and actually get run on the machine, to get indexed before they can do an investigation, just because of the compute cycles. So we're working with, we at the lab are working with Access Data to help speed up this process. They do have a mechanism for, so while they were sort of doing that, they're working with some of our really smart guys who are working on algorithms and all that good stuff for doing this. I sort of took this separate approach and said, well, what if we kept your tool as it is, came up with they have a model for doing distributed computing to access, or to improve the processing. How about we make that more accessible to people? So as a police, if I'm a local police department, I don't necessarily have to go out and buy a rack of servers, or I don't have to have someone who knows how to manage it all, but I simply want to say, I need another cluster, I need an Access Data or FTK cluster to process these disks. So this was really an academic exercise because there are some legal boundaries that are preventing us from doing this with real data right now. But we went and said, okay, how can we take your tool and package it in the cloud? So based on what we've talked about already, it was actually fairly easy to go to the Amazon platform, take their CloudFormation tool, create the appropriate AMIs, build the definition in CloudFormation that says, here's the main processing logic worker, here's the database server, here's 3 workers, here's my networking infrastructure, here's the ports that I want to access, here's my NAS storage where my evidence is going to be, and I want you to provision and deprovision that as a unit. The Amazon CloudFormation and APIs made that really easy to do. Another thing that made that sort of interesting there is their licensing for all of this is pretty expensive. But Amazon, if I take CloudFormation plus their Amazon DevPay, you provide a model by which Access Data can actually bill on a by-use basis. So rather than me as a police department having to fork over thousands of dollars in licensing costs, as well as thousands of dollars for each of these computers, I maybe pay $50 per case to run. And that includes my compute time, includes my licensing costs that get passed back on to Access Data. And Access Data didn't have to maintain the infrastructure, they simply set it up and maintain the images. Right? It was actually pretty easy. Right? Now, as you can imagine, also based on what we've talked today, this is not possible at all today in the Windows Azure platform. Because these are all highly configured traditional software. It's not designed to be packaged in their scale-out way. I have to care about IP addresses when I'm configuring the distribution mechanisms. So I have to be able to manage and script that all sort of at a low level. Yes?
In doing that, you solve the processing bottleneck, obviously, distributing processing, but haven't you at the same time created a bandwidth bottleneck? Now, you got terabytes of data that has to get back and forth to the cloud. That itself takes 5 days or more.
It can take 1. Right? Remember the import-export service.
Okay. That's where your legal handling of the data comes in.
That's the issue that's blocking us is chain of custody on the data. So technically we've solved it, right?
Right.
From a technology standpoint, we have an interesting solution. There are still some very significant legal issues, chain of custody and so forth. How would we manage that?
Especially when you get into forensic,
Yes, well,
data investigations, because
right.
the defense is going to scream, how do we know,
right.
the whole chain of custody.
Right. So one of the things we've been looking at is there's this notion. So there's this notion of what's called ICAC. I forget what the abbreviation stands for, but basically they're regional offices that collaborate together for processing data. It's a Homeland Security agency. Excuse me. And they partner with different state agencies and police departments. So one of the possibilities, if you will, would be to build specialized, if you will, I hate to use this word, private clouds within an ICAC. So if I take a regional area, it's all within sort of a private, federally managed environment. And an ICAC is at most within a state. So ICAPs don't span state boundaries. So there's something more than one per state, but there's at least one in the state. So you're going to have to worry about cross-state boundary issues. But you could imagine having a centralized data center that's managed by one or two people, where they have specialized large collections of these, where they can essentially do this internally, and it's all federally managed and can protect that chain of custody a little bit better.
So a local jurisdiction would just go to the analysis cafeteria, if you will, and
yes, say here's
pull out
what
the services they need.
Right.
Okay.
So again, it's not quite as easy because you don't have the scale of an Amazon, but you may have, rather than having 100 police offices all having their own, you may have a central environment with 50 servers or something like that, right? So we're sort of poking at different options there. Document clustering. So we have another algorithm that we use. We have a group that does document clustering in the cloud, and they do, this algorithm is textual analysis on raw text files and uses a model for saying, if I have a collection of, say, 4,000 documents or 4 million documents, how similar is each document to all of the others? And you can imagine a couple different scenarios where we use this for. One is, I have a large collection of documents that represent some body of knowledge that I'm interested in, okay? And I will run them through the tool, and they'll come up in a fairly tightly packed cluster, right? And that represents my corpus of my known body, known knowledge body. I can then stream additional or new documents past that and have the algorithm tell me how closely they align to this body of knowledge I'm interested in. So maybe I have a stream of documents that I expect to be highly irrelevant, but I want it to periodically catch the one that's very closely tied to these other documents. Monitoring, say, bad guys' network communications could be an example of that sort of thing, right? The problem is the algorithm as it stands today it's technically interesting, but from a computer science standpoint, it's I don't want to say it's naively implemented, but it's simplistically implemented. It was implemented in Java. It builds basically an in-memory tree that's not easily distributable across multiple machines. So we've been working with that group to say, because it's implemented that way, they're limited to the number of documents they can represent and analyze in the tree at any given time. On a moderately equipped machine with, say, 64 gigs of RAM, we're sort of averaging around 600,000 documents at a time, which is a pretty big number, but we'd like to be dealing more in the tens of millions to hundreds of millions of documents, right? So we need to scale significantly larger. So we've been looking at how to do that. This is a highly simplified version of the tree at a point that we're getting ready to scale. Okay, so let's say I've been building up on a single machine, and I'm bringing in new documents, and I have a tree that looks something like this. This is highly simplified because, like I said, at current memory pressure rates, we have more like 600,000 of these. And for every non-duplicative document that comes in the tree, we have a leaf node with 19 steps between it and the root. So you can imagine this would be significantly larger. For purposes of example, we have a tree that looks like this, when we come to the point that we determine that there's memory pressure, we watch across the platform and say, from the top node relative to this particular compute node, which of the direct children represents the largest memory utilization. So I've sort of drawn this up that C3 is the obvious child that represents the most memory. It then makes a decision to say we need to prune that, we need to scale that off to a different machine so we can continue to sort of distribute out, continue to scale, and continue to grow. What we've done is we take an approach like this that says we're going to, at that point, scale out. We're going to serialize the state of C3 to persistent store, spin up a new instance called C3 sub B, rehydrate that serialized state so it comes down, looks like this. And then we're going to leave a copy of C3 sub A here that has the same document vectors mapped in it, but no longer has any of its children. It simply has a pointer that says all of your children are now buffered through this queue using the two-phased queue system within the cloud, and which then provides the input source for this tree. So at the end of the day, essentially what it's doing is it's just buffering, it's dynamically splitting itself and buffering itself via queues, using the underlying cloud APIs to scale itself out to split up new nodes. And this works for us in our case because when a new document comes into the root node, it basically asks all of its children which of you have this closest similarity to this new document, and it picks the one with the highest value so long as it's over a particular threshold. If it's not over that if none are over that threshold, it creates a new node. Otherwise, it goes with the highest winner. This allows it to answer all of the nodes to answer that question, including C3, without crossing machine boundaries. So it can do that before hopping, at the expense of having that document vector located here and here. So you're doing duplicate work for the sake of being able to scale additionally. So in the same way, so I'm going to talk about sort of the overall architecture, then talk about the implementing it on both platforms. In the same way, so that's one aspect of it, is the ability to scale. Another model says, while we're scaling, how do we provide fault tolerance? We've talked a lot today about how fragile, frankly, the cloud is, particularly as you add more items to it. Your MTBF goes down because you have more pieces that are tied to that. So if I'm building a large in-memory model that's now distributed across multiple nodes, how do I make sure that I can continue to grow that more or less infinitely without losing my state and having to re-ingest the entire document set? So what we've done is every time we process a certain number of nodes and we're getting ready to do our memory check, we actually hide or serialize the state of the tree relative to that particular compute node out to persistent store. So we basically, in the HPC lingo, we're doing a checkpoint. Right? We're checkpointing our data so we can, if we were to fail, we could rehydrate from that spot. So if you take a model such that is this, it says we've got 4 servers deployed with 3 queues buffering the communications. And then, for whatever reason, C3 goes belly up. Could be any reason at all. Goes belly up and disappears. We have a health monitoring service, not on the slide, that communicates with each of the nodes to make sure that they're still responding and still alive and still processing. It also monitors the queue lengths of the various queues to make sure they're within reason. With C3 go offline, you notice that 2 things that are happening. One, it's no longer getting a heartbeat response from C3, and you also notice that queue C1, C3 is growing significantly. It's not flushing out data. But otherwise, the algorithm in the tree would continue to build. So long as this queue can grow infinitely, which we get that benefit in the cloud, new documents will continue to come in. If they happen to go down this branch, they continue to go completely unmodified. If they need to come down this branch, they would simply get queued here. This guy continues to run halfway at this stage, right? So we can still more or less run state, even though we're broken halfway through, right? C5 comes online. The health service spins up a new instance, brings it online, hydrates it from the saved state of C3 from the last state. It comes back in. From that state, it automatically knows that it's getting its input data from queue C1, C3. It also knows that the children of one of its nodes is buffered down through C3, C4. And it basically comes back right into the model. And an additional benefit here is when C3 went offline, if it had processed a certain number of messages here that it had not finished, because these are durable queues, it had not committed those jobs, so they will reappear, and we never lost any data. So while our processing slowed down a little bit, we didn't lose anything. We have a very fault-tolerant environment. I think that's it. So we've implemented this both, we're sort of in the early stages on both platforms. We've implemented it successfully both with Amazon and with Microsoft. As you can imagine, both of them have durable store messaging, durable queues, they also have persistent stores. So in many ways, that mechanism works exactly the same. We've had no differences. The only real difference between the two platforms is that the scaling mechanism is harder for Amazon because there's a little more involved in spinning up that new instance and bringing it in the cluster. We have to care about IP addresses and that sort of thing. Whereas with the Microsoft thing, we just say, give me another one, give me another one. Right? So but functionally, there's very little difference. Both platforms solve the problem. Both platforms allow us to use it. It's worked very well. We've got about 20 minutes left. At this point, I have some code that I can walk through that basically shows interacting with any of the various platforms. Is that interesting? Is that boring? Would we rather talk questions? I could do whatever we like at this point. Okay, look at a little code. If you get bored, so the sample that we're going to look at is a guestbook sample. If you played with the Windows Azure toolkit or training kit, this is highly modified, or basically directly stolen from them, with modifications for the Amazon platform. So the way the guestbook works is someone goes to the website, they fill out their name and upload a picture. So here's this little bit of information about me. It gets written to the NoSQL store. So in the Azure world, that's Azure Tables. In Amazon world, that's SimpleDB. The full res image that they uploaded gets uploaded and dropped into the blob storage, whether that's Azure Blobs or Amazon S3. And then a task is generated into the queue that says, go create a thumbnail, here's the URL, here's the pointer to the record, right? Nothing magic there. There's a background image processing service. In Azure, this is implemented as a worker role. In Amazon, it would be implemented as a Windows service or as a cron job, if you were asking earlier. Its job is it continuously monitors the queue looking for tasks. As soon as it finds one, it then acts on it. In this case, it would find a job, says you need to resize an image. It goes out to Blob Store, pulls that down, has an algorithm to generate a thumbnail, uploads the thumbnail additionally to Blob Store, and then updates the thumbnail URL pointer for that record in the NoSQL store. Pretty straightforward, right? So let's look at some code. So the project says end. Can you all read that?
Make it like 110 or 120.
Better?
Yeah.
Okay. Let's come over. Okay. So in both platforms, one of the first things we do is create a model to represent, a data model to represent the entry in the guestbook. Here's the guestbook entry in the Amazon class. So this represents the data that we're going to be stuffing in the SimpleDB. You see it's very straightforward. We have a couple of properties. We automatically generate some values for the query key and name just because. Basically based on business logic, nothing magic that we're happening here. We pop over to the Azure space. Essentially, it's the same exact thing. Nothing different here. The only difference is here they call it partition key and row key, and the other one we call them query key and name. Nothing magic. I think I separated a couple things out here because it's a date time stamp and things like that. But I didn't, from a code standpoint, it's identical. Next thing is the data source. The data source basically represents how we interact with that table storage, what code mechanism we use. So let's look at this is the Azure one. So I create a storage account, so they've got basically using the Azure cloud, sort of cloud standard libraries that they ship. I can create a cloud storage account, loading in my credentials. I create tables from the model that we just created, if I need to. It sets up a data source, and this is, if you've done anything with the entity framework, data source, this is very similar to that. Data set extensions. I do link queries to get my values, get my results, say everything that's for today, and basically query just for the results for the day. I can then return that and then display it on the web page. My ads are very easy. This context that I add, pass in a new guestbook item, and then my update thumbnail entry. I get the result, get the first item, set the new thumbnail, update object, and save changes. Nothing magic there, right? That's very Microsoft, very traditional. Yes?
It's a retry policy. What is it used for?
Excuse me?
It's a retry policy. If you scroll down.
Retry policy. Yes. So this is kind of something you need to, anytime you're interacting with any cloud storage platform, you have to assume it's going to fail at some point. And rather than simply falling over and failing, both the libraries from Amazon and from Microsoft have the ability to allow you to find a retry policy that says if you fail the first time for some generic access, for like a 404, like I couldn't find you, not an error, not like a 500 error, but a 400. I think it's like a 404, something like a too busy error. I forget what the code is. It's 403 or something like that. It says I'm too busy. It will simply retry. Right? So I'm basically in the saying retry 3 times with 1 second in between. So if you fail, retry up to 3 times. But the logic it won't retry it if it's an application error. If it comes back and says your duplicate account or you have some constraint violation, it won't retry. It'll simply fail on those. But if it's a service unavailable error, it'll simply retry.
So is it for every connection? I mean, that setting applies for every time you use the web service. For example, this is one instance of where you're accessing the guestbook, right?
It applies for the context yes, here.
So if you have 10 pages like this, all of them have retry policies?
They can. They can. I'm calling it out specifically here. So basically it gives us the opportunity to talk about it. You can abstract this globally, so you can define it once. In much the same way you would, in a web application, you can put something in sort of your global ASAX and define it there to reuse it on your pages, that same type of thing. So that's the Microsoft version, and the Azure stuff that's come over here to the Amazon thing. So here, I remember we talked about, they call their tables domains. So guestbook entry. I have an Amazon SimpleDB storage account. They've actually done some really good work with their .NET SDK. If you're a Microsoftish person, you download their SDK. It's very easy to use, very intuitive, and particularly if you're into fluent interfaces, you can just do ... and it's almost like speaking an English sentence. It's very, very easy if you want. Here again, the same sort of thing with max error retry 3. Creating a storage account, setting my values coming from the config manager. I create a domain using that domain, basically creating an access to that table. Create the domain if necessary. I want to return, much like the other one, I want to return the guestbook entries for today. So I'm returning a list of guestbook entry objects that we defined over there. Here's very SQL-y, right? So rather than doing link, it almost looks like exactly a SQL string. Select star from guestbook entry where query key equals that passing date. Just like, so again, very straightforward, very easy to look. select request, I do a select request action, get the response. If a result was returned, so you see here I'm having to do a little more work because I'm not able to take advantage of the core infrastructure of the data sets, data services stuff, but it's still not all that bad. So I'm looping through each item in my results, creating a new object. I'm doing a little parsing here. Nothing magic here, but this looks very similar to pulling records out of a database. The type of thing you would see in an ORM, right? Type conversion, type checking, mapping over to my objects. And then I return the objects, and I'm done. And add looks very similar. I bring in a strongly typed object, create a put attributes request. Again, with domain name, with item name. There's notion of replaceable attributes. I go through and set the values that I care about as each object, and then I do a put attributes request. Again, so slight variations, but still very, very comfortable if you're on the Microsoft field. So my point is, there's a lot of similarity between the two platforms so far. If I want to update my thumbnail, I kind of pass the item name and thumbnail, I get the item, I create a new request with a new value, with a single value that needs to be updated, and I say the updated change. Very little magic there.
When you make the query, do you get all the results at a single time, or is it like, unless you iterate all of them all the time?
So both of them have, it depends on the type of query you ask, right? If I'm doing this, let's say I'm doing a query that gives me all of them, right? So I say, give me all that match today. Both libraries have a default that they filter at some level. It says, you never get more than 5,000 in a single request, that's the max, but generally there's a batch size of say 100 or 1,000, I forget what it is, it's configurable in both cases. But there's a default that says, and I think the Amazon size, it says give them the results that equal 1 meg or 100 entries, whatever's you hit first. But in each case, if there are more records that match the query, you get back the notion of, in Azure terms, they call it a continuation token. In Amazon, it's something similar. You basically get a flag that comes back with some weird-looking, GUID-ish-looking string. It's not a GUID, but it's some weird-looking string that you then append to your next. Basically, you see if there's a value there, you resubmit the query with that extra flag, and it gives you the next step. So basically allows you to paging of your results.
Does the API have it built in, or we have?
Yes.
It's built into the API. I mean, do you have to check for the flag and again go through the list, or is it like it's already taken care of?
In both cases, they let you look at it at either side of it. You can take the more lower level and simply say, I still want to use your API, but I want to come in here and I want to be able to see and manage how I go back to it. Or you can take the higher level that says, I want to issue a query and I just want to sit here until you give me the whole thing. And in the background, it's doing that recursive call structure. Make sense? Yeah.
I'm new to all this. There's a primary and secondary key and or token for like the storage to actually bind to it. So you can disable one and then use the other one in case something happens.
In the Azure queue.
Is something like that in Amazon too?
In Amazon, single key. They don't have a separate key.
Does he have like from your configuration manager like username and password? That's it.
Yes. And if you actually looked at my code, you'd see them in there, but it's a dead account. So I didn't worry about it. I actually validated that before I did the WBA. Yep. So we've done that. So we've seen interacting with both Azure Tables and SimpleDB. Things are different but very similar. Right? Let's go over here, see. Come through here and look. Sign up button, click. If the file upload control has a file assigned with it. We initialize storage. We generate a unique blob name. So it's just coming up with a grid and a path extension to the file. You create a put object request. Again, this is the Amazon side. So I create a put object request with content type, with can.ackle, which basically, in this case, I'm using this predefined, everybody can read it, giving it a bucket name, giving it the name, the unique name we generated up there, and the input stream is the file content. I do a response, check it to make sure everything's good, assuming it is. So that's Bubba. Bubba's important. I must have been feeling good about myself when I wrote this sample. And then I trace it out and say I put that file there, and you see us go and do the guest book entry. Pop over to the Azure one. You see very similar code. If my file control has a file, I initialize storage. I create a unique blob name. Again, very similar to the last one, just not as many returns in my line. I create a blob reference, set the content type, upload from the stream, and I'm done. So you see interacting with blob storage and S3 are almost, again, the constructs are slightly different, but the approach is very, very similar, very much the same. And then we go through the data source. So we've talked about, okay, we need to look at queues here real quick. So we've looked at interacting with storage, interacting with tables, queues. I basically get a queue reference to the queue in particular, create a new cloud queue message, which here is just a string. Add this message to the queue with a single line, and I'm good. I come over here, create a new send message request. Queue is to the URL rather than the queue name, essentially the same. Give it a message body, send the request. So there's, as far as using the cloud primitives on both platforms, from a coding and language standpoint, it's almost functionally identical. Very, very little difference. With that, I'm going to pop back over here. That's not what I wanted. Because our time's basically up. Any other questions you'd like to talk about? Problems, solutions?
I know it's fairly easy working on Azure to kind of know if you're on the cloud or not. From your point of view, how hard is it to actually develop a whole application that could work on a local instance, like network drives and all that, and also just switch it to?
So I'm actually that document clustering algorithm. The core algorithm is actually implemented in C++. Even though we do recompile it, but that same code runs on the Jaguar supercomputer. It also runs in Azure. Also runs in Amazon. Now around that core algorithm, we have platform-specific scaffolding, if you will, stuff that's specific for that environment. So we have stuff that's allows us to interact with storage mechanisms in the supercomputer, and then in the cloud. Now, in the cloud environment, there's sort of another layer of similarity between Amazon and Azure. But then, if you follow, we've applied a lot of what would be considered traditional good coding practices, in that we use things like the repository pattern for interacting with our storage platforms. We use provider models for implementing things. So, when I interact with blob storage or persistent storage for my files, I've abstracted from my main code logic via the repository pattern the differences between Amazon and Azure. So as I'm moving between the two, yes, I have to change some code, but it's very specific. It's very few places. The same with my queue structures from messaging. Same for table structures, right? That's abstracted out. So, and if I needed to run it all in-house, my repository pattern would simply go against my whatever local NAS or SQL database or whatever, right? So the point is people talk a lot about vendor lock-in.
if you have properly designed applications, the deltas between them are abstracted to the fringe of your applications, right? So moving between them, while it may, particularly for large applications, may be non-trivial, you shouldn't be touching or messing with the core function of your application. Does that make sense?
Yeah.
I think last year there was an Azure demo where they made a client just for Azure only, but they made it talk local storage and then talk to cloud storage, and the transition, and the program didn't know, and didn't care.
The difference there, they were probably using the dev storage, so the emulator,
Okay.
which I think is different from the question. The question is if I'm using cloud storage models versus using traditional internal to my data center or on-premise storage models like file servers and things like that.
The Azure SQL is pretty seamless from.
Yes, if you're using SQL Server, it's very similar. It's not identical, but it's very close. So unless you're
The
using
main thing is the connection strength.
right, unless you're using features in your on-premise SQL Server that don't exist in SQL Azure, which there are some, then if you're not using those, it's just a connection string difference. Thank you so much. Use your free services if you want them. Great talk.